So our second section of chapter 11 is still on solving quadratic equations, but this time we're going to be doing it by something called completing the square. Now, this is kind of a weird method. Like I mentioned at the end of 11.1, you won't really use it that much in this class. When you're told to solve a quadratic equation, you can normally choose which way you want to solve it. Most people normally don't choose completing the square because it is kind of weird, but you will be using it in 126. So you need to just kind of be familiar with it. And you'll notice the homework assignment for this section is like 9 problems long because we don't focus that much on it in this class. So as a quick review, so far what we've seen for solving quadratic equations, the number one go-to method should be factoring using the zero factor property. Number two, we saw this last time, is the square root property. And again, it's something that you can use when you have some quantity being squared equal to some number. And so this is our third method. This will be completing the square. And again, it's something you probably won't choose to use unless you, for some reason, really like completing the square. And then the last method we'll see in 11.3. So let's go ahead and take a look first at what completing the square means. So completing the square means making a perfect square trinomial and so let's go ahead and look at what perfect square trinomials are. So perfect square trinomials are something like this. So something like x squared plus 8x plus 16. Now, this is a perfect square trinomial. And so let's see a couple reasons why. This last number here should always be a perfect square, which 16 is, it's 4 squared. And then the middle term, now if we look at 16, 16 is 4 squared, and if we double 4, we get 8. So there's some kind of relationship here between the last term and the middle coefficient. And then this, if we went through and factored it, would turn into x plus 4 squared. So it gives us some quantity squared, and then we'll eventually use the square root property when we're solving these. One other example of a perfect square trinomial is x squared minus 10x plus 25. So again, just kind of identifying that this is a perfect square trinomial. This last number is a perfect square. It's 5 squared, and 5 doubled is 10. So we always have that relationship there. The only difference here is that this middle number is a minus, which just means we'll have a minus in our factored form. So it's always the square root of the last number. And then the sign will always match what you have here in the middle. So that's going to help us when we get to actually solving some of these. Now let's go ahead and look at some examples. Couple of different examples here. The first two, what we're told to do is we're going to find what must be added to make a perfect square trinomial. Then factor. So this first one's actually set up really nicely for us. We're given this here. So we're given t squared minus 2t plus blank equals And then in parentheses, they've given us t minus blank squared. So they have pretty much this whole thing set up for us. We're just going to be filling in the blanks. So first thing we want to do to figure out this part right here, if we think back to what we had over here, to get the 16, if we take half of 8, so if we take 8 divided by 2, we get 4. And then if we square that 4, we get 16, because this is 4 squared, which is 16. That's what we're going to be using here. And so what we're going to do in general is take the middle term, and if you remember, we're given a squared or ax squared plus bx plus c. We're going to take the number in front of the x, so we're going to take b, divide it by 2, and then square that whole thing. This is key. So this is what we're going to be using a lot in completing the square. So let's take negative 2, divide it by 2, and then square it. Well, negative 2 divided by 2 is negative 1, and negative 1 squared is just 1. So you'll notice because we're squaring it, this last number will always be a positive, so it'll always be plus. And then over here, this is going to be whatever we get here, but square rooted. So it's going to be the square root of 1, which is 1. And they've already put the minus because we have a minus in the middle. So this one was kind of half done for us. Number 2 here, we're given x squared plus 4x plus blank, and then we're going to have to go ahead and factor that. So again, we're going to take this 4 in the front of the x, divide it by 2, or take half and square it. Half of 4 is 2, and 2 squared. I'll keep the parentheses just because in the case of a negative, you want to make sure you have those. 2 squared is 4. So in this case, we're adding the same thing here. That's just because it's a 4. That's one of those kind of special cases. Now, if we go ahead and factor it, we're going to always have parentheses squared. This first term will match this first variable here. So since it's an x squared, we're going to have an x. And because we're squaring it, that'll give us that squared. Now, because it's a plus 4x, we'll have a plus. And the square root of 4 is 2. So this is the factored form, and this is the number we're adding to make it a perfect square trinomial. Now let's try one more before we start solving some of these. This one we're given an m squared plus 5m plus blank. So this is kind of one of the ones where, well, this is the reason that we don't like to use this method a whole lot, because it can get kind of messy. So if we take our coefficient here, so 5, divided by 2, and then square it, 5 and 2, well, 2 doesn't go into 5 evenly. So I'm actually going to go ahead and just square the top and the bottom. So we get 25 over 4, and let's fill that in. And so on the right here, parentheses squared, it's an m squared, so m in the front. We have a plus in the middle. And now the square root of 25 over 4, square root of 25 is 5, square root of 4 is 2. So we have m plus 5 over 2 squared. That's why these can get kind of messy, because if you don't have an even number in the middle, you're going to end up with a fraction at the end. All right, so let's go through about 5 or so examples on how to actually solve these. So we're told to solve using completing the square. Now, a lot of these, well, some of them you would be able to use some of the other methods we've talked about. So square root property, which we'll actually use in completing the square, or the zero factor property. Some of these are factorable, but for the sake of this practice, we're going to be using completing the square. If they're not factorable, then we do actually have to use some other method. And so in this case, we're using this completing the square method. So this first one here, we're given n squared plus 6n equals -4. Now, the goal with completing the square is to do what we were just doing on this last page. So we're going to complete that trinomial on the left and have a perfect square trinomial when we factor it. So first thing we're going to do here is you always want to make sure that your n squared and your n terms are alone on the left-hand side, which this case they are constants on the right. That's what you want when you start. So this one's actually set up pretty nicely for us. What I'm going to do though is I'm going to make a little space after the 6n so that we can complete the square. So we're going to have n squared plus 6n plus something. And now remember that what you do to one side, you have to do to the other. So we're actually going to add it in both places. So if we go ahead and complete the square, we're going to have 6 over 2 squared. 6 over 2 is 3, and 3 squared is 9. So we're going to add a 9 in on both sides. Now, this should make factoring pretty nice. You should have a perfect square trinomial here on the left. So we're going to go straight to factoring that. So it'll be something squared, n squared. So we're going to have an n in the front. It's a plus, so we'll have a plus sign. And the square root of 9 is 3. So again, n comes from n squared. So you basically square root this side, square root to the right side, bring down the sign in the middle. All right, that's the left side. The right side should just be some computation. Make sure you square that. I forgot to put that there. -4 plus 9 is 5. Now, this should look a lot like one of the ones we saw in 11.1, where we use our square root property. So we're going to go ahead and square root both sides. And on the left side, the square root and the square cancel. We get n plus 3. On the right side, remember, when you square root, you want to put plus or minus. Square root of 5 cannot be simplified, so we'll just bring it down as the square root of 5. Now let's subtract this 3 to solve for n. And just like I did in 11.1, I'm going to put that -3 right in the front. So it's -3 plus or minus the square root of 5. So the solution set is -3 plus the square root of 5 and -3 minus the square root of 5. So kind of breaking down what we did here, in this first step, you want to make sure we'll write it like this: ax squared plus bx is alone on the left. Or in other words, move the constant to the right, which we already had here. In the second step here, we are completing the square. This third step, going from the second step to the third step, we factored the perfect square trinomial. And then the entire last part here, we solve using the square root property. So the only actual completing the square part is maybe one step in the beginning. After that, it's the square root property. That's why we needed to cover that in 11.1 so that we're able to use it here. All right, let's try another one. Number 2, we're given x squared plus 2x minus 10 equals 0. So remember our first step, if we look back to our last set of instructions here, the kind of steps for solving these, let me add in the step numbers. First step is to make sure that the x squared and the x are alone on the left side, which they're not. We want to move our constant to the right. So we get x squared plus 2x. Now I'm going to leave a space here for when we complete the square. Put that space on both sides. Now let's go ahead and complete the square. So we're going to take our middle coefficient, 2, divide it by 2 and square it. 2 divided by 2 is 1, and 1 squared is 1. So let's add 1 to both sides. Now we factor the left, so we're going to leave our parentheses squared. It's an x squared, so x is in the front. Now we have a plus in front of that 2x, so plus, and the square root of 1 is 1. So we have x plus 1 squared. On the right, we have 11. Now we'll use our square root property to square root both sides. And so on the left here, square root and square cancel out. We get x plus 1. On the right, don't forget your plus or minus. Square root of 11. You should be getting 2 solutions for all of these. If you're not, you probably just left off the plus or minus. So continuing along, if we solve for x, let's subtract 1. Again, I'll put it in the front. We get x equals -1 plus or minus the square root of 11. And again, 11 cannot be simplified, so we're going to leave it as -1 plus the square root of 11 and -1 minus the square root of 11. All right. Let's go ahead and do a few more. Number 3 here, we're given x squared plus x minus 3 equals 0. Now, this is when they start to get kind of ugly. These last 3 actually are all going to be not super nice. These ones, the first 2 that we've done have worked out somewhat nicely because we had an even number in the middle. If we look at this one, we have just an x, which is the same thing as a 1x. So it's going to be a little messier. We will have some fractions, but it's doable. So first things first, let's get the x squared and the x alone. Let's add the 3 to both sides. We have x squared plus, I'm going to leave it as 1x, leave a blank, and then let me fix this line here. It's going to get in our way a little bit. It's a little bit better. On the right, we have a 3 plus the blank. Now, if we go ahead and take our middle term, so 1, divide it by 2 and square that. Well, they don't divide evenly, so we're going to leave it as this, but we're going to square the top and the bottom. 1 squared is 1, 2 squared is 4. So we're adding in 1/4 to both sides. Now, the factoring is still going to be nice. If we factor the left side, this x squared is x. It's a plus in the middle. And the square root of 1/4, square root of 1 is 1, square root of 4 is 2. So if you notice, it's exactly what we had in these parentheses over here. And that should be right, because going backwards from squaring something to square rooting, they're inverse operations, so we should be able to go from one to the other. Now, on the right side here, we have 3 1/4, and I'm actually going to go ahead and combine those into an improper fraction. So 3 1/4, if I go ahead and use the conversion between a mixed number and an improper fraction, we're going to do 4 times 3, which is 12, plus 1 is 13/4. So I'm going to do that just because it's going to make square rooting both sides a little bit nicer. So if we go ahead and square root both sides, on the left side, like usual, these cancel. We get x plus 1/2. And on the right, plus or minus. Now the square root of 13, we cannot simplify, but the square root of 4 is 2. So we have the square root of 13 over 2. And if I subtract this 1/2 to solve for x, we have x equals, I'm going to put this negative 1/2 in the front, plus or minus the square root of 13 over 2. So you can write your answer, either leave it like this. Not sure if my math lab will complain. Sometimes they're picky and they'll say your answer's right, but it's not in the right form. So if they say something like that, what you're going to want to do is you're going to want to combine our fractions together. Now, normally they would be good like this. So this is kind of an either or situation. So if we go ahead and combine them, they already have a common denominator. So we're just going to have -1 plus or minus the square root of 13 over our common denominator of 2. So our two solutions here are -1 plus or minus, whoops, not plus or minus. -1 plus the square root of 13 all over 2, and -1 minus the square root of 13 all over 2. All right, now let's go ahead and look at just 2 more of these. Number 4. Now these are ones that are kind of annoying to use with completing the square because there are some extra steps, but it does show up in the homework and you could see something like this in 126. So we do need to cover it. Number 4, we're given x minus 5 times x plus 1 equals 2. Now, first thing we want to do is put it in that form where we have ax squared plus bx equals c. So we're going to have to multiply out the left-hand side. We'll go ahead and FOIL. So we have x times x is x squared. X times 1 is x. -5 times x is -5x. And then -5 times 1 is -5. Now I'm going to go ahead and combine like terms, and then I'll get it equal to the constant. So we have x squared. 1 minus 5 is -4x. Minus 5 equals 2. Now, if we get this equal to the constant, I'm just going to move this -5 over to the right. And I'm going to make a space after that 4x. So x squared minus 4x plus blank equals 2 plus 5 is 7 plus blank. Now let's go ahead and complete the square. So we're going to take our middle term, and now I'm just going to ignore that negative because we don't care about it, because when we square our number, we're going to have a positive either way. So I'm going to take 4 over 2 and square it. So 4 over 2 is 2 squared, which is 4 on both sides. Now we can factor this left side. We're going to have our parentheses squared. So x squared is going to give us an x. Now this one is a minus in the middle, and the square root of 4 is 2. Again, it's what we get before we square that 2 over there to get that 4. Now the right side, 7 plus 4 is 11. So let's go ahead now and use our square root property and square root both sides. Don't forget your plus and minus on the right. So on the left, we get x minus 2 equals plus or minus 11 cannot be simplified, just square root of 11. Add the 2 to both sides, and we get x equals 2 plus or minus the square root of 11. All right, so that one, the difference between this and the others we've seen was that first step where you have to get it into our completing the square form. So it's not already multiplied out. You're going to want to FOIL it and then get the constant on the right. One last example here, and this one is kind of why we never use completing the square when we're just solving a regular quadratic equation. it can get really ugly. So let me go ahead and show you this one. So we're given 2t squared minus 3t plus 3 equals 0. Now, one thing to notice here is that, first of all, our constant isn't on the right. We'll deal with that in a second. And also, we don't just have an x squared or t squared in the front. We have a 2t squared. Now, one requirement for completing the square is that you have to have just a t squared in the front in order for us to do this special factoring here. So what we're going to do is we're going to have to divide every single term by 2. So let's go ahead and do that. And now this is why these can get really ugly. Our first term is just a t squared, which is nice. But then in the middle, we have minus 3 over 2t plus 3 over 2. And on the right, 0 over 2 is still 0. So it's kind of ugly, but we're still going to go through and use completing the square. So we want to get our first 2 terms alone on the left. So let's move this 3 over 2 to the right. And I'll leave a space. So t squared minus 3 over 2t plus blank equals, now we have a negative 3 over 2 plus blank. Now let's go ahead and actually complete the square. So we're going to take this 3 over 2. Now we want to divide 3 over 2 by 2. So if I just wrote it like this, it looks really ugly. So instead of writing it like that, what I'm going to do is think of, and I'm actually going to go ahead and do this up here. So we have a little bit more room. 3 over 2 divided by 2, we can, instead of dividing by 2, multiply by the reciprocal of 2. So we have 3 over 2 times 1/2. And now remember, we do want to square this. So we're going to take 3 over 4 and then square that. So we're going to have a 9 over 16 added to both sides. Now, if we go ahead and factor the left, it's still going to factor nicely. We're going to have a t in the front, a minus, and then the square root of 9 over 16 is 3 over 4. And on the right, we're going to have to do some addition here. So we have negative 3 over 2 plus 9 over 16. So let's change that negative 3 over 2 to a common denominator of 16. So let's multiply by 8. So negative 24 over 16 plus 9 over 16. So if we go ahead and do that, we're going to get a negative 15 over 16. All right, now let's go ahead and square root both sides. And we'll cancel these out. So we get t minus 3/4 equals, now the square root of a negative, let's not forget our plus or minus. Square root of a negative is I. So I'm going to bring that I out in front. Square root of 15, I'm going to leave that on the top. And now this I is going to just stay here on the top for right now. Square root of 16 is 4. And so let's go ahead before we bring this over, make sure that you can't simplify the square root of 15. 15, you either have 1 and 15 or 3 and 5. So no, it cannot be simplified. So let's go ahead and add the 3/4 to both sides. And remember, I'll put it right there in the front. We get t equals positive 3/4 plus or minus I square root of 15 over 4. And again, you can leave it like this. I'm going to combine it into one term. So we're going to go, we already have a common denominator. So it'll be 3 plus or minus I square root of 15 all over 4. And so our two solutions, we're going to have 3 plus I square root of 15 over 4. and then 3 minus I square root of 15 all over 4. All right, so that is why completing the square is not super nice. If you get the process down for the nice whole number questions like we saw back in the beginning, it's not terrible. It's just this first part for completing the square that's kind of funky, and then it's the square root property. But once you get into those problems where you have an odd number in the middle and you get fractions, it gets kind of messy. So practice the nice ones, get the nice ones down. That way, when you see it in Math 126, it's not quite as bad. Next, we'll be seeing the quadratic formula, which is kind of the fallback option whenever you're solving a quadratic equation and you can't factor. And then we have word problems and we'll be done.